Hello again, Mr. Flores class, and thank you for having me as your guest today. I really enjoyed meeting you all, and I felt really badly that we didn't get to finish our presentation and our discussion, so I thought I would go ahead and make a short video so that we could wrap things up. Do you remember this slide where we left off saying that HVAC is typically what uses the most power in most buildings? And then when the bell rang, we were on this slide here. This slide was developed to show that electrical engineers must do a lot of calculations. We have to decide how much power a building needs based on the equipment inside, the lighting, the size of the building, and many other factors. We show how this power is distributed in a building, typically with what we call a riser diagram, which is shown down here. This riser diagram will explain the different breaker sizes, like this is 100 amp, 225 amp, 200 amp, and 150 amp, and those go to various panels within the building. When I say panel, I mean this piece right here. A panel has breakers in it, and each breaker serves an electrical circuit that serves things like receptacles or equipment or lighting circuits. Anything inside a building that has a wire will be served by a circuit in an electrical panel. Electrical engineers also specify lighting. We decide what kind of lights go into different areas, and then also the controls that control those lights. Also, we specify safety equipment like this disconnect switch here. This is an on-off switch so that if somebody's working on a piece of equipment, they can turn the equipment off and disconnect it from the electricity so that nobody gets hurt. Moving on, I want to talk about plumbing engineering a little bit. This example that I have shown is a Little Caesars Pizza restaurant. Actually, I call it a restaurant, but it's really more like a Little Caesars pickup place because there's no place to sit here and dine. But this shows water coming in to Little Caesars, and this plan over here shows all the wastewater going out. In a restaurant type of kitchen here, a lot of this water will have grease in it, so it has to go through the lines and then it has to go through this big box that's buried underground called a grease trap, and that separates the grease from the water so that the grease does not get put back into the city's utility system. Every once in a while a big truck will come and it'll remove all the grease out of this grease trap. So plumbing engineers and construction design water systems and waste systems for buildings. Have you ever thought about where your fresh water comes from? Well, it comes from the utility company, but then once it gets into your building, that's when the plumbing engineer will design all the piping inside the building. And sometimes a little bit of piping outside the building as well, but usually it's mostly within the building. There's a whole world of plumbing below us that we don't even see, with piping that runs for miles and miles. Plumbing engineer designs the piping, valves, and pumps required to move water from the city utilities into our buildings for kitchens, restrooms, laundry rooms, drinking fountains, etc. And if I was there with you, I would ask you of other ways that you could think of that it might serve buildings. A plumbing engineer will also specify or select the type of toilets that go into a building, the type of lavatories and sinks that go into a building, and there are a number of different plumbing fixtures that they will select, but these are just a few. And then there are also several things that you will not see in the building that plumbers have to design. Like this particular diagram down here is of a backflow preventer. And what a backflow preventer does is it prevents water from flowing back. So if you look at the direction arrow here, the water is supposed to go from blue to red and into the building. Now once it gets into the building, it is not allowed to go backward. So these valves here are designed in place to make sure that that does not happen. This meter over here that you see, whoops, a little too far. This meter right here is a gas meter. Again, from the bottom, the gas comes from the city utility. It goes up, it goes through a regulator so that it has the correct amount of pressure, and then it goes from this pipe into the meter. This is the gas meter that the utility will read to know how much to charge the people for this building. And then it comes out of the meter and then into the building to serve things like furnaces, water heaters, gas ranges, and things of that nature. Fire protection engineering will be the last type of engineering that I talk about, and I'll go through that pretty quickly for you. Basically, fire protection engineers, their sole job is to keep people safe by providing systems like sprinkler systems and fire alarm devices to let people know when there's an emergency and they have to get out of the building quickly. Fire protection engineers will deal with all of these types of devices. Smoke detectors, you probably have these in your house, so you know what those are. Heat detectors, which are similar to smoke, but they detect heat instead of smoke. And sometimes in buildings you will see both of these. There's another type of device here too, where you can actually, in a building, you can break the glass here and it'll send a signal to a central unit. And this is a computer basically called a fire alarm control panel. This control panel lets all of these notification devices know that they must send a signal to the occupants in the building, and it also sends a signal to the fire department to let them know that there's an emergency. Fire alarm protection is very important. It is a life safety issue, and people need to be highly trained in this area. Okay, now that we have talked about the different types of engineering and focused on mechanical, electrical, plumbing, and fire, I want to tell you a little bit about the different levels of jobs that you can find in an architectural or engineering office. First level would be draftsman, and a draftsman is somebody who has completed a certificate, that they have done some training and taken a class or maybe a series of classes in programs such as AutoCAD, or there's another program in 3D drafting that's called Revit, and those types of things. The draftsman will start out at a certain dollar amount. I can't tell you exactly what that dollar amount is because it ranges from place to place, and it pays different salaries in different areas of the country as well. But we're going to use that as our baseline salary and say that a draftsman starts at $1 sign, and then we're going to compare all the other levels to that dollar sign. The next level would be a designer. A designer is somebody who typically has some college, maybe a 2-year degree, like an associate's degree, and they know more about the systems, the mechanical or the electrical, plumbing or fire systems. And so they have some education in that, and therefore their credentials are a little higher, so they will earn a higher salary than the draftsman. The next level is a graduate engineer. This is somebody who has actually gone to a 4-year college and earned their bachelor's degree, and they know quite a bit about the engineering and design of the mechanical, plumbing, fire, and electrical systems. Again, the higher credentials, the higher salary amount. And fourth, this is our professional engineering level. These people have gone to school for 4 to 6 years. They probably, well, they definitely have at least their bachelor's degree. They may have a master's degree as well. They have also taken a series of very difficult tests to prove that they are competent in the engineering profession and that they are knowledgeable enough that they can actually certify and sign off on drawings to tell that they are safe for the occupants who will be in the buildings that they design. And as you can see, their dollar amount is the highest here. They are also typically the people who own the businesses, the engineering offices, or the, in some cases, an architectural/engineering office. So I want to thank you for your time and for your patience and for all of your participation in our discussion today. If you have any questions, I would be happy to answer them. Mr. Floor has my email address, and so I would be more than happy to answer any emails that you might send me. Now, are you ready to get to those raffle prizes?